All right, here's the equation. FO equals FS times V plus or minus VO divided by V minus or plus VS. Don't worry, I'm going to tell you what all these things mean. Okay, let's start with the F's. So FO is the frequency observed / heard. FS is the frequency made, or the source frequency. God bless you. V is the speed of the wave, which is usually going to be the speed of sound. So how fast does the wave go? And by the way, the wave goes 340 meters per second, unless I tell you otherwise. VO is the velocity of the observer. And Vs is the velocity of the source. All right. One last thing to mention. What's up with these signs? This plus, minus, minus, plus garbly-gook business. So here's what's up with them. The top sign in both the numerator and the denominator is the sign you use for towards. When things get closer together, use the top sign. When things get further apart, you use the bottom sign. So TT, top towards, that's how I remember it. Notice I did not say plus is towards and minus is away. I didn't say that because that's not always true. Yes, in the numerator, plus is towards because it's the top sign. But in the denominator, plus is away because it's the bottom sign. All right, we need to see this in action because it doesn't make sense until you've seen one solved out. So let's solve them out. Flip to the backside. All right, Logan and Quentin are far off from one another and are yelling in funny accents. Logan decides to one-up Quentin and make a really funny high-pitched sound, so he makes a frequency of 763. In addition, Logan charges at Quentin with a speed of 12 meters per second in order to make him cower in fear. Quentin, up to the task, also charges at Logan at 7 meters per second. What frequency will Quentin hear? And then we'll talk about B after that. So, for starters, we need to decide who's the source and who's the observer. So the source is the person making the sound. The observer is the person hearing the sound. So, what frequency will Quentin hear? He is the observer. He's hearing it, which means the source is Logan. Then we need to figure out all these things. FO, FS, V, VO, VS. So, FO is the frequency the observer hears. What frequency will Quentin hear? It's question mark. FS is the frequency of the source. My source is Logan. Logan makes a frequency of 763 hertz. V is the speed of the wave. The wave is sound. And sound, as I mentioned, has a speed of 340 unless I tell you otherwise. VO is how fast the observer is going. Quentin is the observer. It says Quentin charges at Logan at 7 meters per second. Logan is the source. It says he charges at Quentin at 12 meters per second. All right, we got all the numbers. Now we're ready to plug them in. FO equals Fs times V plus or minus VO divided by V minus or plus VS. So we've got everything ready to go except for the signs. That's the only thing we have to do left. We figured out who the source and the observer were. We figured out what the numbers were given in the equation. Now we're ready to figure out the signs. So the signs I told you were top, towards, bottom, away. So I need to ask myself, each of these two, and I'm doing them separately, are they going away or towards? So let's start with Quentin, who's the observer. So Quentin is the 7. It says he charges at Logan at 7. So at is towards, so he would use the top sign, which is plus. Then I look at Logan. Logan charges at Quentin, so he's the source. He goes towards, at is towards, so he also picks the top sign, which is minus. So all we have to do is add and subtract the numbers here. So FO equals 763 times 340 plus 7 is 347. 340 minus 12 is 328. And then we divide those numbers out. So 347 divided by 328, 1.06. And multiply that by 763. $807.2. So Quentin doesn't hear a sound of 763. He hears a sound of 807. It's not the same. It changed because they're going towards each other. They're getting closer together, not further away. Questions on that first example? Yep.
So for like the frequency observed,
Yes.
like the very last part, you just add them together?
So I did the 7 plus 340 to get 347. I did the 340 minus 12 to get 328. I divided those to get 1.06. I multiplied it by 763. Okay? All right, let's look at this second example. At a short amount of time, Quentin's resolve fails him, and he turns around and runs away at 7 meters per second. What frequency would he hear now? So it's the same thing. FO, what am I solving for? None of the numbers have changed, so I'm just going to go ahead and write them all down. 763, 340, plus or minus 7 over 340 minus or plus 12. So what does change is the direction. So I ask myself, okay, is Quentin still going towards? No. He turns around and runs away. So I need to pick the bottom sign for Quentin, which is minus. However, Logan, his motion is unchanged. So he is still going to be going towards, which is the top sign, which happens to be a minus. So this time, it's FO equals 763 times 340 minus 7 is 333 divided by 340 minus 12, which is 328. 333 divided by 328 is 1.02. Multiply that by 763. You get 774.6 hertz. Now wait a minute. We just got done saying that when objects get closer together, the frequency goes up. When objects get further apart, the frequency goes down. 774 is still bigger than 763, even though Quentin ran away. So why didn't that change? Why is it still the same? Yeah, or why is it still higher? Yes, because Logan is actually still getting closer, because 12 is more than 7. So Logan is getting closer more than Quentin is getting away. So the frequency is still higher, but it is not as much higher. It's a little bit higher. And there you have it. That is how Doppler effect works.